Hello guys, welcome back with another video. Today we're going to talk about the weak interaction. We're going to talk about the hydrogen bond and the covalent bond. Basically, the hydrogen bond is the attraction which occurs when hydrogen atom bonded to a strongly electronegative atom such as oxygen, nitrogen, and fluorine. And the covalent bond is the electron shared between two atoms, such as an example of the hydrogen bond, we have water molecule. And another example of a covalent bond is the chlorine, which is, let's do it with the dots. Each chlorine has 7 electrons. As we see right here, these two electrons will share together to form a bond. Therefore, we call this a covalent bond. Each of these hydrogen atoms have partial of positive charge. And each of the lone pairs on the oxygen atoms have a partial of negative charge. The bond between the oxygen and hydrogen, it's a weak bond and it's longer, and the bond between the chlorine atoms is a stronger bond and shorter. Therefore, it needs more energy to break down the bond, this bond. And for this one, it needs less energy to break up the bond. And now we're going to have an example of the water molecule interacting with neighboring water molecules. So the H2O molecule is polar. The partially positively charged hydrogen atom of one molecule of H2O can interact with the partially negatively charged oxygen atom of another water molecule. So let's put that in an example. So if we draw a water molecule and another water molecule and another water molecule, and as we know, the positively and the lone pair is in here, and as we know, the partial negatively charged on the oxygen gonna be, and the partially positive charge on the oxygen. So the partially negative charge will react with the partially negative charge as, let's say, let's do another color. So it's gonna be right here. This lone pair will interact with the hydrogen, and here is the same. And now we ask a question: is the hydrogen in the water molecule, is it donor or acceptor? Of course gonna be donor, because the water molecule is donating a hydrogen bond to a hydrogen to another water molecule, and the same for other water molecules, they donating the hydrogen. Now let's talk about the electrostatic interaction. The electrostatic interaction, also called ionic bond, usually takes place between atoms bearing a completely negative charge and a completely positive charge. They are weak because when you put the ionic bond into a water, they completely will dissociate into ions because of its polar characteristics. But as a solid, they are tight bonds. They stay together. Example of this: when salt added to water, it dissolves. The ionic bond between the sodium and chlorine is destroyed because the individual's ion now binding to the water molecules rather than to each other. Uh, let's draw a cup of water, and it has water in it, and then we add salt, NaCl. As we know, the Cl is negative charge and the sodium is positively charged. This one right here is metal, and this one, the chlorine, is non-metal. This is always, and we add them to the water. As a solid, they stick together. As a solid. And when we put it in the water, that's what we're gonna get. They will dissociate into ions. So under the water, they will be sodium positively charged and Cl negatively charged. They will dissociate. The salt in the water molecule will dissociate into ions. So basically what is happening is the water shields the ion charges. So even the sodium is the positive charge and the water is negative charge. The water surround the charge get shielded. Hopefully guys this video made clear for you, and thank you for watching the video, and don't forget to subscribe and like. Thank you.